Hi all, um, I'm Rahmat. I am the team leader of this project entitled Optimize Greenhouse Gas Protocols Based System for Carbon Auditing. So our team members are Dr. Yaya, Sudarya, Triana, and Dr. Emil Kaburuan. We are from Informatik Department, Fasilkom, UMB. Our partner, Associate Professor Azam Osman from USM. This research is under KLN grant scheme with the contract number of 0251599 BSPKV 2024. I will start with introduction and then follow by the proposed idea. Then we present the implementation, result and discussions, and we end up with the conclusions. As the world continues to grapple with the challenge posed by climate change, the need for robust environmental and carbon audit solution has grown. To develop the robust solution is a challenge because the parameters of the emissions are very complex, causing low accuracy result. This is our proposed idea. So we developed CO2 emissions calculator with the incorporated feature selections methods to this system, and using the well optimization algorithms as optimizer to produce greenhouse gas model for energy usage. We only consider two formula from the GHG protocols, which is scope 1 and scope 2, expressed with by this equations 1 and equations 2. To implement the system, we use the dataset from audit, the publicly available, specifically for our country, Indonesia. The dataset contains CO2 emission from year 1900 to 2021 with 78 features. So we take the total greenhouse emission as dependent variable, and the other 72 features, including population, GDP, annual carbon emissions per capita, annual carbon emission per GDP, annual carbon emission per unit energy, etc., are considered as independent variables. So we formulate the well optimization algorithm as follow. So we set the decision variables, which is the generation level of carbon, and the process parameters, the 76 features as vectors, using equation 1 and equation 2 I introduced previously. And then we set the objective functions to minimize the carbon emissions, which is the total carbon emission and carbon intensity. Then we also set the constraints, which is power demands, emissions limit, and resource availability. We initiate the populations and the set parameters, and we set the parameters for the well optimization algorithm with the population size of 100, maximum iterations of 100, and some control parameters. And then we start with this step, evaluations, search for prey, encircling prey, and bubble net attacking. And then we continue with the update positions to update all whales position based on the selected search strategies. And we terminate after we reach a satisfactory solutions, and otherwise we repeat step 3 until step 7. So we implement the system, the proposed system, using computer with a processor of i7, memory of 16 gigabytes, and storage of 1 terabytes, running Windows operating system. And the algorithm for optimizing the emissions calculation is implemented using Python programming language. We present here the results for carbon emissions prediction. You can see here that the prediction is so close with the actual data. Also for this greenhouse gas emissions predictions, and we also evaluate the emission model for carbon as well as for the greenhouse gas. So we found out that the algorithm we use converges relatively fast, i.e. after 20 epochs or iterations. This fact supports the computational efficiency of the algorithm, and making this computational efficient compared to some other meta-heuristic algorithms, because the algorithm has a relatively simple structure, not so many iterations, not so many recursive process. Yeah. As conclusions, well, our experiment results show that the proposed emissions model represent well the real data carbon emissions, and for future works we consider to implement paired well optimization algorithms as an enhancement of the standards algorithms. And also we plan to incorporate uncertainty or considering additional constraint here. In this occasion, we would like to thank the Research and Technology Directorate of Universitas Mercubuana Jakarta. Thank you so much.